Well, thank you, everyone. Well, my name is Isra. It's my nick handle. Well, I want to do this talk because over the last year, one thing I realized is that one of the most important things for developing, for writing code, is not really what, if you know a language, you know some libraries, or you know some framework, or you can like write very algorithms that are very efficient in like inverting trees or whatever. Probably you have seen a lot of this in interviews. It's more about this. Probably many of you have seen this many times in your life. Whenever you have in your career, when you're at work and you want to, and you look at some code that your colleagues or you have written in the past, many times you say, what the fuck is this? I don't understand what this code is doing. And I think this is very bad. I think probably many of you have had this situation where you see something and you see this is super weird. And I think this is something that many times we overlook and we don't give enough importance, but it's very important. This system is so weird. Because I think that even if we don't realize, this is one of the main reasons of delay of projects or failure, because if you don't understand very well what the code is doing, you need to spend a lot more time on reading it and trying to check if this works this way, or asking your colleagues how it works, or if it can fail because you can spend too much time and then say, okay, it doesn't work. Also, it's a source of very like horrible sneaky bugs, because if you don't understand the code, probably you mess it up. We do it all the time. And I mean, yeah, if you don't understand it, it's very easy to, if you didn't know that this variable had to be this value because otherwise it breaks, and it's in a comment in the top of the file and then you didn't see it, you're dead. Also, at least for me, it's a source of developer suffering. If I need to read a code and say what the fuck all the time, I'm suffering when I work. It's not that I don't like it. And many people, I guess that if they're in a job where every time they have to deal with shit, they say, okay, this is shit. I don't like to do this. I want to work with some code that is nice, or I can understand, and I don't have to be all the time fixing bugs that appear because the whole system is a mess and that doesn't work correctly. And it's also that something that is contagious. If you're working in a code base that has a lot of messy code, probably the code you're not going to say, okay, I'm going to fix everything. You're not going to do it because it's a lot of work. And since it's already wrong, you say, okay, I can like add this function is already like 1,000 lines, 3 more lines is not going to be bad. So probably it's contagious, and I think it's not good, because instead of learning how to do it better, you just imitate what the bad code is, and then you don't learn. Well, I said clean code, what the fucks, but I put some some definitions or some ideas of what, of course, for every of you, clean code can mean a different thing. It's not that, there's not a definition of, also it's a matter of taste. Some people like more functional programming, some other people prefer it to be more like procedural with, and then modify things in a different way. But well, some definitions here, the one I like the most, because I think at least is the one that comes more with me, is that it reads like prose. It's something that you read and you can understand. Then elegant and efficient, this is very subjective. Elegant, what is elegant, and efficient, well. Also, something I mentioned before, it makes it hard for bugs to hide. If it's really hard to see if you are doing something wrong, it's not good. This is the next one is, I think, quite important, is that you don't need to, it can be enhanced by another developer rather than the original author, many times without having to ask the people who wrote the code to help you with it. Sometimes you say, okay, please, can you come and explain this to me, because I don't understand. For me, this is not clean. This is like bad, and you don't understand. You constantly need to bring people in to help you or read a lot of documentation. It's probably not good. And also that it's obvious how to use it. Provides an obvious way to make things. So you don't need to read like 3 pages of documentation to understand if these attributes you need to put one thing or the other. Okay, Then, well, other things I will say here are probably subjective, of course, and probably there are a lot more things to do, and some of these things you might not like, but yeah, this is what I got. So the first thing is something very stupid, but it's easy. I don't know if you will agree, but it's something as simple as this. Use the common style guide for the whole team. And this is not, in my opinion, this is not just because it looks pretty and whatever. It's because, in my opinion, when you look at code that is formatted always the same way, it's easier to understand. If some developer writes a line like this size and then the code is like compacted or whatever, or you have all the functions that they are separated the same space, probably it's easier for you when you look at the code just to read it. It's stupid, it's very simple, but a lot of people don't use it, and I think it's quite easy to. In Python, we have the pep-egg and other extensions. I don't remember the name of the enhancement proposals that have a common way for all developers to write the code more or less in the style. You don't have to follow it like very strictly, and you can relax some things, like for example the width of the lines. Many people say, okay, 80 characters is too few. But you can integrate this with your continuous integration system and also with Git hooks. So every time you commit, you make sure that you at least the rules that you want to follow, you follow. And also you don't need to like write this, like learn all the rules yourself. You can have normally the editor can auto-format it. This is well, if you don't know what, I don't know if it looks okay. If you know what this kind of is a linter, you know how it looks. Is something like that. You can like be writing and it tells you what you're writing that doesn't match the style. And not only the style, it also helps you with sometimes when you are coding. And then if you are using some variable that you didn't define or something like that, it tells you, okay, but you are using this and you didn't define it, or you are defining this variable and then you are never using it. Sometimes it helps you with other stuff. Well, this is clear. It's very basic, whatever. So, well. Next thing I think this is again very basic, is use meaningful variable and function names. This is like from 101 of coding, is write, instead of writing variables that are just one letter or two letters or three that you don't understand, write something that makes sense. Because, well, we can be lazy, but most of the editors have to complete. So why do you need to write like cryptic things like an S, L, whatever, or red, when you can write what you are meaning? Because in this way, when the person reads the code, it's easier. This, for example, this piece of code is quite small, but if you have a big piece of code where you have S and L and R and red, say what the hell is it? And then you have to go to the top to see where it's defined and say, okay, leg, L is a leg. Okay, then I understand. But if it's leg, you already know. So like this, in my opinion, this doesn't look so good. I think it's better if you write the full name. Well, sometimes something against like using full name is that they're very long, and of course if you want to keep the width like reasonable, it can be hard. But my answer to this is like try to use the context. It's not, you can have a variable name segment. If you have a function where you're dealing with one segment, you can, a segment is since I work here on travel, segment is a travel segment, okay? It's one flight, for example. Then you have only one variable, only one type of segment, you can call it segment, because in that function, it's just one segment. But if you are in a context where you have multiple, perhaps you want to like say, okay, this is segment, first segment, or second, or all the segments, whatever. So for example, in this case, what was a very stupid case, where you have perhaps you already have a class that is called address. You don't need to add address to all the variables. You can just skip it, and from the context, when you do address dot street, you already know that this is street of the address. You don't you need the full name. Okay, this is something I added recently. It's like also the names. It's not only about the names of the variables that you create. Also, it's something about if you are using, sometimes we use functions that have multiple arguments, And if you have one or two arguments, sometimes it's easy to understand. But you have multiple of them. This is like a almost real example I took today. For example, you come here and say, yeah, I'm calling this with true in this argument. What the hell? What the fuck is this? I don't understand why I'm setting this true. What is this? I have to go to this class to get the init method and understand what I'm doing. But if we set the keyword arguments in here explicitly, it's easier to understand. I don't know, perhaps I should have I didn't have into account that people cannot see this at the bottom, but you get the idea. It's like when you have a lot of arguments, use keyword arguments. Otherwise, also keep the number of arguments small, but well, at least here you know what you're doing. Also, this is something I usually do, but some people might not like it, is that you can also like create variables to hold what you would put in a conditional. Sometimes you can see code that will say if and a long string, and then you see some comment on the top of the if saying, okay, if this is doing that, perhaps what you can do is like write a variable that has the idea, the meaning of what you are checking in the condition, and then use that to check the condition. This way, when a person reads it, the person understands what you are writing in the conditional. I have here two examples. They are almost real examples. And also, apart from writing it in a variable, you can also use a function. You say, okay, if I want to name this condition, I say, okay, I don't know, if it's readable. And then it's readable is that it has the readable parameter inside. Okay, but then I can check this, and I don't need. Usually, if it's so simple, you don't need it. You have to use common sense. If it's this is larger than 3, you are not going to write a variable say larger than 3 and then use it. But if it's a complex conditional, perhaps you can get it out of that line and describe it. Because in the end, some people say that comments are lies. Comments, you write a comment above or close to something, you can probably update the code and forget to update the comment. But if you write the code itself, it's much harder to forget that you are changing something, and then you will change the code, and the code what you read will be what you really mean. Okay. Okay, next thing that is also quite obvious, this is short, is like functions and methods and many other things. Is like a single responsibility principle that many of you have probably heard about, is that functions should do only one obvious thing. When you read the function and you read, for example, get the birthday, it should get the birthday. It shouldn't get the birthday and at the same time alert the system if you are doing something and then check permissions of another thing. Then you need to be careful about what you do with the function and name them correctly. Okay. Well, as an example, I got here one example of a function that does two things. One thing I usually don't like, and for me it's a coding smell, is when you have a function sorry, that returns a tuple of some two things that are 2, 3, or 4 things that are not homogeneous. It's not like you're returning a list of something that is the same type. Is that you are calculating multiple things at the same time in a function because you might have your reasons, but you mix stuff, and then in the end you return the tuple. And then for me it's a sign that you are doing multiple things. Also, if in the name, when you're thinking about the name of your function and you cannot think of one single thing that it does, it's probably because it does multiple things. So in my opinion, that's not very good and contributes to not really being able to follow the whole flow. Okay, so next one, that is also, I feel like most of the things I say, they are like really easy and really obvious in some way, but I think that even if we already know, it's good to think again about them, and have and keep them in mind, because when we are writing the code, it's easy like to be very sloppy and I want to be fast and whatever, but then you remember, okay, but I can name this variable something good instead of R. Okay, I remember from the talk, I will do it. Okay, here is like, you have very long functions, try to break them into small ones, so it's easier to read. And in this case, what I usually like to do is like get away from the computer for when you say, okay, I want to do this process. I don't know. I want to compute the total, the sum of the amount of the invoices for the month for this client. Okay, then instead of just jumping to the code and get the code and start copy pasting, think first, how would you explain this if you were speaking to a non-technical person? Not thinking about the objects and everything, and say, okay, if I want to, for example, calculate the amount of the invoice for the month, I would like to get the invoices, find the invoices that are for this month for this client first, and then get their amount and add their amounts. So you think about it, and perhaps you can even write it in a notebook. Probably you can understand that these are perhaps 3 functions that you can use, and then 1 function that gets everything, and then you can add everything up. So for example, something that is also a coding smell many times is that you get a very long function, and you get like blocks of code where things are done, and you get some comments sometimes over it, like, yeah, do this, and then we do that, and then we do this other thing. Of course, you can keep it like that, because you can understand, and reading the comments, you can understand. But it has, in my opinion, for example, this advantage that, well, it's a lot more, you need to look at the comments instead of the code, and then sometimes it's harder to see what it does in a glance, and also it's a lot harder to unit test and to reuse parts of the code. For example, coming back to the example of the invoices, perhaps you want to get the invoices for the month for a client for another thing, not for adding the amounts. So you already have a function that does this thing, which is something that has logic in itself, then you can reuse it. If you just put all the code here, probably what you end up doing is copy pasting. You will say, okay, this is how I do this, and this is how I do that. Well, this is an example where, like, to get the duplicated trips, we get like a hash of the trip, and then get all the trips for the same company. We want to have them as possible candidates of duplication, calculate the signature for every other trip, and then check if the signature of these candidate trips is the same as the signature of the first trip that we calculated. This is very long, and it's perhaps hard to read, but we can like create multiple small functions that we can give a name. This is the main function where we say, okay, first we want to get the signature of my trip, then I want to get all the possible candidate trips, and then return all the trips that match the signature. And every one of, just here is also very important, the same way as I write the code, is like keep the same level of abstraction for each, within a certain scope, try to keep the same level of abstraction. So instead of having a big block of code where we do something very low level, try to say, okay, to do this, I need to do this, this, and that, and then get inside what you need to do to get the trip signature, okay? And then to get a trip signature, I need to do this, this, and that. And perhaps you have multiple levels, because you say, okay, then I have another level, which is get signature, which is another level. So in the end, it's like a cascade of things that you have in mind, like a high level, that you can explain to a non-technical person, and then you go level by level until something that is very specific, and yeah, but you don't need to explain, and you don't care. Some people, you don't care how you calculate the signature. It's not important. The signature for the assignment, you don't care, but you still understand what I'm trying to do here. Okay. This is the example I gave you before, like the total invoice amounts, get the invoice for the month, and sum the totals. Okay, you have 2 pieces here, and these 2 pieces of calculating the total amount for the month. You can like decompose it in multiple things. I think this is quite important because, in my opinion at least, it makes the code easier to read, more modular, and easier to test. So yeah. Also, something related to this is that the shorter the functions are, usually the complexity of the cyclomatic complexity or cognitive complexity is going to be smaller. This complexity is not about the O and is not about the big O notation of complexity in time and space. It's about how easy or how hard it is for you to understand the different paths within a function, the different paths that the code can go. So you have a lot of, for example, this is an example I got from Flake 8. You have, every time you have a conditional, it adds 1 point of complexity in this hypothetical measure. Yeah, every time you have an if, a for, it adds a branch for the code to go to that branch. And something that also adds a lot of complexity is having like returns and breaks in the middle of the functions. Because then you have to say, okay, but this part of the code will never be executed because we have a return in the middle, and only in one case. Then you say, okay, but this code is doing something, but it should work like that. But then you didn't realize that you had a return hidden in the middle of nowhere. So it's like super hard. So here again, we have a very long function. Well, very long, it's longish, with that has cyclomatic complexity of 6. You don't need to know how to calculate this. There are linters that tell you, for example, I think Flake 8 tells you about functions that are too big and too complex. And other systems like Code Climate and SonarQube that you can check and they tell you, okay, this part of the code is quite complex. You have like huge functions and they are very complex. So you can refactor the previous thing to like have less conditionals and have only one way of, so the flow here, you know how it's going to be, and you don't have breaks or anything in the middle, so it's easier to read. Usually it's always related to splitting the function into multiple ones. So it's every time you read a part of the code, you can concentrate only on the part of the code that you a very small thing, because you think about it, when you code, you have to understand multiple levels of abstraction every time, and there are so many that it's really hard to understand what the code is doing if you don't have them clearly defined. If every time you look at some part of the code, you need to understand all the levels at the same time, you need to understand all the concepts, it's really hard. But if you get a small thing, like we saw before with invoices, like when you add if you add this, and you have 3 steps that are easy to understand, you don't need to know what's happening below it, it's much better. So in the end, yeah, if you can get to a point where you can forget about the low-level code and just follow the logic of the higher level, it's much better. Well, next thing is something that is also very common and very like theoretical in the world of object-oriented programming, is the principle of least knowledge. Also, I think it's the law of Demeter, I think. It's all about encapsulation and information hiding, and it's related to what I just said about, like, you know that up to this level I understand the code and I care about the code, but there's a part of the code after this I don't care about the low-level implementation, and I don't have to care because I know that this thing is being computed some other way and there's a boundary that I don't need to touch. I don't know, for example, when you use any framework, when you use Django like we use here, you know that when after you do you try to get an object from the ORM, you have a syntax and you use it, but you don't know what's going on behind, and you don't care very much. You know that it does some SQL, but you don't touch it. And this is the good thing, because it's called cognitive compression. You need to understand SQL to use the system. If you had to understand SQL to be able to use the system, it would be much worse. With hiding part of the system, so you don't need to care about it, you can be more powerful, write faster, and write better code. So some practical things that can do to hide the madness, the internal madness of like low-level processes, and like processes that you don't care about because your boundary is in here and you don't care about writing SQL. Well, first one is the rule of only one dot is called the law of the emitter. It's about not trying to not care about the internal structure of the object that you are using. So you don't know. Well, I will show you later. Well, rule of only one dot. Don't think about the internal structure of the objects. Also, something is that it's not very common in Python, because in Python every attribute is public. It's not like Java or other languages where you can say, okay, this thing is private and nothing can touch it. But in my opinion, the fact that in Python you cannot really name method or a variable as private easily makes you not think about what should be touched and what shouldn't be touched and what's private. Then you access the attributes directly and you do change a lot of stuff. So so you can end up messing with the object and rendering it into a non-useful state, or that doesn't make sense. I will show you later. Also, something at least I have not seen a lot and we don't do very often is create more classes to hold the data and the logic. Many times what we use is dictionaries to pass data around, and when you have objects that don't have any schema and any methods, everything is a function that predates that data model and does things. But you don't have logic that is specific to the data. That is the encapsulation. When you encapsulate data and methods and functions is what you are doing with encapsulation, and what is good, because what you will see. For example, this thing about the invoices, summing the amounts for the invoices. Okay, in the example here, for example, we need to know that the invoices have items, but perhaps when we are dealing with the code of adding up the amounts for the invoices, we just care about the amount of the invoice. Why this function needs to know that the invoice has items? We don't need it. What we could do is say, okay, I want to add all the amounts of the invoices, then it's the invoice, the one that has a property or a method or whatever, to get the amount knowing its internal structure. So you are passing the responsibility instead of to the caller, to the object that is being called. And this helps a lot, for example, to avoid like defensive code where you have to say, okay, but then every time I want to calculate this, I need to check that the invoice has items, because if it doesn't have items, well, I don't know. Also, if you later change this and then you need to do some VAT calculations, you can say, okay, I need to do VAT calculation, then the amount is not going to be so easy as just adding this up, and then I have to compute it in some other way. Then you only have to update this function, and the rest will automatically work. So it's good, so you don't have to change code in multiple places, and also to bind the concepts to the object that you are creating. Here, you know that the amount is something that the invoice can compute of itself without needing an external function to go and tell it how to do it. So whenever you find that you have a function that you are applying to an object, that the object itself will know how to calculate this thing, probably you can put this as a method of the object. Okay. Also, like similar to this, like it's an example usually used when you think about the law of the only one dot is if you wanted to ask a dog to move, you will say, okay, dog move. You don't say to every of the leg move forward. So you have a method for the dog to say, okay, move, and that's it. I don't need to know that you have legs. Perhaps you have 1 leg, 2 legs, 5 legs, I don't care, just move. And the same way this also helps you with polymorphism. You say, okay, I have multiple animals, and the different animals have a fish, and a fish doesn't have legs. But I don't need to know. I don't need to know. I only have to tell you to move. This way you differentiate the internal structure from the external thing, and you don't need to care about it. Polymorphism. Also, something very important to avoid having to be very defensive about the code is avoiding impossible states. Something like a typical example You have a wallet with money, and you don't want to for the amount of money to be below 0 because you cannot in a wallet. It's not a bank account. Then what you could do is say, okay, every time I try to pay, I have to check before every time I have to check if there's enough money. But then it's every time you call it. But if you get and abstract this and put it into a method of the class, every time you use it, instead of accessing the attribute directly, you just use this method and you can put all the defensive logic there. And also things that need to go together. For example, whenever you set a price, you need to set the amount of the currency. If you manipulated the attributes alone, perhaps you forget to set the currency, and then the next function that comes and expects the price to have a currency and you forgot about it, is going to explode, and you're going to have a runtime error. This way, you make sure that all the stuff you store in the object makes sense. Also, perhaps you cannot create a wallet with minus 30 euros, stuff like that. Okay. More about, this is about the impossible states. You have also related to the fact of the idea of not putting the data just in dictionaries, but create a class for it, is that you can add logic to the data, which is the encapsulation. You just have a dictionary with all you can nest dictionaries perfectly, but you don't have, what you don't have is methods, you don't have functions that apply to this data. And if these functions are just restricted to this data, you can create a class and say, this is the class, and these are the things I can do with the price. And you can convert, you can say, I have this function that converts one price to the other, and then since in the price you already have the currency and everything, well, you can do a lot of things much easier, in my opinion, than having to deal every time with internal structure. If you don't care about internal structure. And yes, there's more stuff like that. You use dictionaries, just can create something that doesn't make sense, and every time you need defensive functions. You say, okay, every time I use this, I need to be careful, because what if I have a flight without legs or without segments, and then when I want to compute the duration of the flight, it doesn't make sense. Or perhaps it makes sense and you get a 0, but then when you get to the next function, that one is going to explode because it's trying to sort whatever, and the 0 is going to like, you pass all the errors instead of controlling the errors at the point where they are produced, you continue passing the errors, the code is going to explode later, and the bug is going to be harder to catch, because, oh yeah, but then in this case there were no segments, and what was the direction, inbound or outbound? I don't know, because there are no segments. What do you do there? None. You put none, and then, oh, none has no, the length of none cannot be whatever. It's the same. It's very bad. So, well, that's it. Probably you have read this thing like premature optimization is the root of all evil. I believe it is. Why? There's a full quote saying like in 93 or 97% of the cases, like premature optimization at like micro optimizations are not important, and what you have to concentrate on is like the big O, like the order of complexity of your algorithm. But but I think it's not only about the premature optimization to get performance, but it's, I think, also something that is bad, in my opinion, for software development, and is very important in startups, is to avoid premature flexibility. Is like avoid you having a code that can do a lot more than you need to do, because every time you add a feature to your function or to your classes that you don't need, some flexibility, and you don't use it, is more code that you need the next time you will need to understand. Many times I would look at code and say, okay, but this part, this function, well, this is never used. Then why do we have it? I don't know, we put it there just in case. Just in case what? You can always add it later. So because you're not gonna need it, just keep it simple. I think when you're designing code, the most simple it is, coding the functionality that you need is what you need. You don't need more, and it will make it easier. Because even And many people say, okay, well, no, because what happens, I'm gonna create this and I'm gonna make it like you can plug this template engine in case you want to change it in the future. But then, okay, if you wanted to like extend something you have in your code base for the future, if the design is simple, it's not gonna be hard. You can add it later. So if you are very sure that you're gonna need that feature, okay, you can do it. But don't design for flexibility always just because it can be a possible case. The same way in a startup, you just don't do everything a startup can, something that the client might want just because they might want it. You do thing by thing and validate everything. So here is the same. And also the more code you write, usually you do test-driven development, the more tests that you need to add. And the more branches that there are, and in the end, the harder it will be to understand. Then about, when you are in this process of like adding features, I think it's very important to do continuous refactoring. Is whenever you write something simple and then you want to enhance it, it's not good to just say, okay, but I have this possibility and then I just add more code and it will work and more until it's a shit, everything. You need to think every time, okay, if I did this that was simple and then I continue adding code, but there might be a point where I say, okay, I need to refactor this. So something that I thought it was going to be simple is not so simple anymore. Then let's refactor. So it allows this complexity with new abstractions that you can understand. For example, things that you can do when designing system, avoid arguments that you can add to functions that you don't know you're going to use them. For example, imagine you are displaying you have a blog and you want to display the blog post. And you say, okay, but I want the function to get the posts in Django. And then I want to be able to sort them by date inversely or like from the oldest to the newest or the other way around. But perhaps you don't need it because in the end, who orders the post from the earliest one to the latest one? You don't do it, so you don't need it. Why do you need to add this piece of code there that is sometimes not going to be used, and then it's going to lower your test coverage? And well, I don't know. Perhaps you introduce some bugs in the parts of the code that you don't use, and someday it's used, and then you don't have test, and it's broken. So if you don't need it, don't create it. You can, from here to here, it's so simple that you can do it. It's not hard. So my point of view is that you don't need to add the complexity beforehand before you need it. Also, even if a lot of books and texts about clean code, sometimes they say, okay, yeah, but you need interfaces for everything. Well, my point of view is, well, it depends. If you are sure that you want to plug different systems, for example, here in templates, you can say, okay, I'm going to use templates, but then I'm going to create some abstract interface that is the template engine. And the template engine, I provided this and that, and then I create a subclass that uses Jinja to use it. But what if you only have one template system? Why the hell do you need to create all these abstractions with all this code that you need to understand? Perhaps you can use it right away. And the time when you come and you say, okay, then I need another system, instead of just appending some shit here like Jinja to if else, perhaps you can come here and say, okay, now I want to refactor and I want to do it right because it pays off. Also related to premature optimization for performance, sometimes this is the root of all evil in the case of in my opinion, it's better to try to optimize first for readability, and then in the case you know that it's going to be super slow or it's very critical and you need it, just then optimize for speed. For example, in this case, you want an early break here and you say, okay, I want to check if this flight has luggage, and of course, the first leg that has luggage, then we know it has luggage, then we break because we don't want to look at the rest. Because, well, it's very expensive. Well, it's very expensive or not. Perhaps it's not so expensive. I don't know. Then perhaps it's better to like write it in a way that you don't need to think about, okay, I have a variable here. Well, this is wrong because This I didn't check the code, but this won't work because I assigned this. This is a function that is also a variable here. It won't work. But imagine that this was a function to calculate if the leg has luggage, and then if I need to think about, okay, I have a variable and then I have a break in here that breaks the flow. So it's easier to just do like this. So concentrate on it being easy to read, and then you can optimize later. And I found, yeah, fast. Okay, it's very in the end. Okay, a tool that a lot of people don't know is Line Profiler. A lot of people know about the profiler for Python that you can use, but you get the name of the functions that are being used. But there's something called Line Profiler. Look on the internet, and then you put a decorator to the function that you want to check, and you run your script or your test or whatever, and then you get a line-by-line analysis of where the time is spent. So it's very good when you have written your code and it looks good. Then you say, okay, I want to see, oh, this is taking a lot of time. Then I will optimize it. Okay. Well, I had a cut in here, but it doesn't appear. It looks there. Well, something a lot of people don't look at is that in my opinion, tests are also code, and if they look if they are really ugly and they are hard to understand, a lot of repeated code, you will have to spend a lot of time every time you add some feature refactoring them, and they will break. So the same way that you write good code, write good tests, because otherwise you're going to spend too much time. Related also to testing, it's I don't know, many people don't know about the pyramid of testing. It's I have seen many times when you are testing a system, there are some tests that test the system more in integration, but they are very slow, more slow. For example, you have end-to-end tests. They are very slow, but test everything. Adds a lot of value, but they are brittle and they are slow. And there are some other tests, like unit tests, that are fast, but of course only test one component, or one class, or whatever you want to call it, one unit, but don't test the integration. So the practice is, if you splitted the code in a way that you have like small functions, you can write a lot of tests for these small functions, and then have less tests for the whole integration. And then you can test, for example, the happy paths with the system tests or UI tests and integration tests, and then test extensively your units using unit tests that are a lot faster and a lot more predictable. Because those the tests at the top are harder to maintain and need more time and are very brittle, I can tell you. And also something also related to testing is the cost. Many people in TDD, they say, okay, we have to test everything, and because it's very important to test everything. And there is some article that I agree with, is that the value, the benefit of unit testing is correlated with the non-obviousness of the code. You have code that is trivial, that is just, it doesn't make sense to say, okay, I have a function that creates a dictionary and assigns these values, and then create a test that checks that this function does this. If it's obvious, you are like repeating, sometimes you are repeating the code of the code that you did, you are repeating it in the test. It doesn't make sense. So in the end, what adds a lot of value is, for example, to test stuff like algorithms. You have an algorithm that calculates if this flight is earlier than this other one, and you give it all the values, and then it does some calculation, and you know the right output. Okay, this is high value and low cost because it's very fast. It's fast to write and fast to run. There's code that doesn't make sense to write at least unit tests for, because it's trivial, just something that you assign a variable value. There's coordinators, all the stuff that you like bind together, and then if you wanted to unit test the coordinators, you have to mock almost everything. So in the end, you wouldn't be testing anything. You would be testing, yeah, I mock this, and that, and then it does this. If I mock everything, it works. But then when you use the real component, it will blow up, because what you mocked is not really what's going on. So do integration tests for that. And the code that is really complex because it's very algorithmic and then has a lot of dependencies, this code needs refactoring. So you can separate what is the coordinators from the algorithm. So you can test this with units, and this one you don't need to test because it's something that doesn't add a lot of value. Well, some resources I wrote about, like you probably know about the Robert C. Martin books. Some of the things I wrote in the presentation is from Clean Code, about the variable names and how to do the cascading of the functions, keep them short, low complex. And Clean Architecture also talks about how to structure the pieces of your app. And it's one set of books that I have not read fully, but I think it's very interesting to learn by example. The same way I say, if you work in a messy code base, you're gonna get bad habits. If you look how many of the projects of open source are made, there are a lot of people with a lot of time making them very beautiful. There's, I don't know, remember what AOSA stands for, but there are like interviews and articles written by maintainers and founders of certain open source projects where they detail the architecture they follow with the project. So this is more related to architecture, but I think is useful when you think about your code and your project. Well, and that's it. I don't have more things to say.